through the gas laws lab really quickly. So once you click on, when you open the lab procedure, just click on that hyperlink and this will pop up for you. And you can see on the top, you can switch between the 3 different gas laws that we're going to be dealing with. So this is Boyle's law, and you'll notice that you can change pressure or volume. If you change one, then the other one's going to adjust automatically. Temperature is being held constant here. And then if you're in Charles' law, now I can change temperature and volume, but pressure is held constant. And Gay-Lussac's or Amonton's law, I can change pressure and temperature, but volume is going to stay. So if we're starting with Boyle's law, you can see the molecules, those little red balls there. Those are molecules that are gas molecules that are bouncing around there. And you're going to have your procedure here. It might also be helpful to have your data sheet open so you can kind of answer these questions as you go along. So, which variable is held constant here? It's going to be the one that can't change. Use the volume control arrow. So first you're going to change the volume. So I'm going to use the volume control arrows. Notice that it's starting off at a pressure of 1 and a volume of 3. And it says to reduce the volume. So I'm going to push the down arrow down to 1.7. And so when I do that, I change the volume over here. A new point shows up over here on this graph of pressure versus volume. And they're asking me to describe, discuss the collisions. So what's happening to these molecules? Are they colliding more? Are they colliding less? And if you're like, oh, I missed it. Well, what did it look like when I was at 3? So, whoops, this is 3, the volume of 3. Now, when I reduce the volume, what happens to those molecules? You can kind of notice how fast they're moving, how much they're hitting each other. Go down to 1.7. That's kind of what we're asking. What's happening? Describe those collisions. Great. And then that was part 3. Using the equation for Boyle's law, calculate the pressure. So now we're going to calculate that, and then you can confirm your calculation by just pushing calculate. So to find the pressure, oops, right? We have P1V1 equals P2V2, P1V1 equals P2V2. So pressure 1 is over here. That's 1. My first pressure is 1.00. My volume is 3. My pressure 2 is what I'm looking for, and then my volume 2 is 1.7. So I would just divide both sides by 1.7, and then that's how I would get my pressure 2. P2 ends up being what? You can calculate it, and then you can just push calculate, and it'll tell you that that's 1.76. So you should confirm that that's also what you got, right? If I just did 1 times 3 divided by 1.7, yep, I got 1.76. Good. So that's that first part of there. And then you want to press the reset button. Up here is the reset button. Reset that. And then here we go. Right, using the pressure can now change the pressure control arrows. Reduce the pressure to 7. 0.7. You can't go up to 7. 0.7. So what's going to happen when I change the well, actually, what did we notice? Let me go back. What did we notice when we changed the volume? I decreased the volume. What did that do to the pressure? The pressure went up. It went from 1 to 1.76. So what is going to happen here if I reduce the pressure? So down here is showing you where if you're like, there, 0.7 is there. What will happen now? It went up. So if when I decreased the pressure, the volume went up. You're going to then collect a whole bunch of points over here. So you have your initial one. So now you're going to collect a whole bunch of points, specific points. So you're going to reset that again. And then if you go back to the procedure, it tells you, you have your P1, your V1. That's already set at 1 and 3. That's not going to change. And then now we want to do 4 more points. So they say to increase the pressure to 1.5 and then measure the volume. So I'm going to increase the pressure and I'm going to measure the volume. And then do the same thing for pressure of 2 and 2.5 all the way up to 2.9, only because this doesn't actually go to 3, it ends at 2.9. So you're going to measure those pressures, and then you're going to calculate that. So I'm going to do different pressures so that you can't just copy my work. So I did 1.3, and then I'll show you how to analyze this data. So I did, I changed the pressure to 1.3, and then I calculated that. and then I'm going to say add data, and now I'm going to go over to next. So you don't do 1.3, you do 1.5 and 2 and 2.5 and 2.9. I'm going to do these other ones so that I don't just give you all the answers. You don't want all the answers, you want to try to get it yourself, right? 2.1, and then I calculate that, 1.43, do another, oh, dang it, 2.1, right? Now add data, so you're collecting those points, 2.6, you can either hit calculate, or if you do add data, it'll just do it for you. And then 2.8, calculate, done. So now I'm going to write all those in my chart over here. So I have 1, 1.3, 2.1, 2.6, 2.8. I got the same thing. And then I've got those values. Great. Now we're going to put that in Excel. So now I'm just going to left click on this, right click, copy, and then I'm going to open up an Excel table. And I'm going to just put that in here, paste it. Sure. All right, so I have my pressure, I have my volume. Now I want to find 1 over volume. So to find 1 over volume, I'm going to, you can do it by hand if you want to, or you can take advantage of using Excel, and you're going to type equals, and then click on this guy. Just left click on that, and then, 1 divided by that. Sorry, equals 1 divided by, now click on that. So equals 1 divided by that. You get this. And then if I click on that cell, and then I left click over here until I see that, see how that's the white plus sign, now it becomes the black one, then I can drag that down on the corner, and it's going to copy that equation all the way through. So this is going to equals 1 divided by C3, and this is 1 divided by C4, 1 divided by C5, so 4 and so forth. Okay. So what we want to do is make a graph of 1 over volume versus pressure. That's what they're asking you for. So I'm going to highlight this column, and then I'm going to control and highlight this column. So that lets me highlight both columns. I'm going to go to Insert, Charts. I'm going to do an XY scatter. Great. And then I'm going to confirm that everything's on the right side. So over here, I want 1 over volume. This side should be 1 over volume. Does that make sense? So my first point is showing up at 0.3. Yes. And 1. Yep. So this is my X. X is 1. That's what I want it to be. Good. All the way up to 2.9. Yep. And then my 1 over V is over here. Great. I want to add some axes titles so I don't get confused. So I just clicked on that little plus sign, and then checked the thing that said axes titles, and then go over here, double click on those to kill them. This I want 1 divided by volume. Again, your numbers might be different because you're doing 1, 1.5, 2, 2.5. Don't put these numbers in. I want you to put the ones that we asked for in the lab. So 1 divided by volume, and that's in, liters to the -1 or 1 over liters, however units, whatever you want to express those units. And then down here is my pressure in ATM. Great. What else do I want to do? I want to add a trend line. So there's lots of ways to do that. I'm going to left click on that, and then to highlight it, then right click to the add a trend line. This thing pops up again. If I scroll down to that is adding a trend line already for me. I can display the equation on the graph there. That's great. And then I'm going to actually add a chart title too. I'm just going to call this one Boyle's Law. So then you want to add this chart to your final data sheet. You can click on it and then right click and copy it, and then you can bring it over to your data sheet. You can either paste it right in here on question number 7, or I think it says add it at the end of the document. That's fine too, wherever you want to do it. So then you would just put paste, copy paste. Now they're going to ask you some, conceptual questions about this. Is this proportional? So 1 over volume versus pressure, that's proportional. Or we would say pressure and volume are inversely proportional. So if I increase one, the other one has to decrease. And that should be what we see over here, right? So I'm increasing the pressure, and volume starts high and gets lower. So that's kind of what's happening with Boyle.